In this question, we have a point charge is placed at the center of a hollow conducting sphere of internal radius r and outer radius 2r. And then they're asking us to find the ratio of the surface charge density of the inner surface to that of the outer surface. Now let us take a hollow conducting sphere of inner radius r and the outer radius 2r. So we are going to point a charged particle at the center. So let us take Q positive. So the center is positive plus Q. So the inner surface is minus Q. So this is Q minus. So obviously the outer surface is less positive. So here they are asking us to find the ratio of the surface charge density of the inner surface to that of the outer surface. Now we know that the surface charge density sigma, which is equal to Q divided by 4 pi r square. We are going to get the ratio of the surface charge density of inner and outer surface. So let us write sigma I, which is equal to Q divided by 4 pi r square. And the outer surface charge density sigma out, which is equal to Q divided by 4 pi, the radius is 2r the whole square. Now we are going to get the ratio of inner surface to that of outer surface, which is equal to Q divided by 4 pi r square divided by Q divided by 4 pi 2r the whole square. If we cancel out this 4 pi and 4 pi, Q and Q, remaining will be having r square and r square also after cancelling out will be having 4 here. So we have 4 divided by 1. So the ratio of surface charge density of inner surface to that of outer surface, which is equal to 4 by 1. So the final answer is 4:1. So the answer is 4:1.